It is May 4th, 2023, and you are watching The Code Report. Python is a wonderful language for productive programming, but it has one big problem. It's too slow, and going slow means you'll get made fun of by the Rust and C++ chads of the world. But the tables are about to turn thanks to a brand new programming language called Mojo, a superset of Python that's not just 2 times faster, not 10 times faster, but up to 35,000 times faster than your grandpa's Python. And that's a huge deal because Python's the dominant language for artificial intelligence, but behind the curtain, anything that needs to go fast is written in C or C++. In today's video, we'll take Mojo for a spin, but first, here are 5 things that you need to know about it. 1, this is not some random guy's side project on GitHub, but rather it comes from a company founded by Chris Lattner, the guy who created the Swift programming language and the LLVM compiler toolchain. If anybody could fix Python's problems, it's him. And if you have no idea what LLVM is, check out this video. 2, it's a language designed for programming on AI hardware, like GPUs running CUDA and other accelerators. It achieves this by leveraging multi-level intermediate representation to scale to exotic hardware types without a ton of complexity, and it even has built-in auto-tuning to optimize your code for your target hardware. 3, it's designed as a superset of Python in the same way TypeScript is a superset of JavaScript, so you don't need to learn another language to take advantage of it. And this is unique compared to other modern systems languages like Rust, Zig, Nim, and so on, which would have a higher learning curve for existing Python programmers. It does have a bunch of features on top of Python, like var and let declarations and structs, but the base language is fully compatible with Python, and it can also interop with the Python ecosystem, which means you can still use your favorite libraries like NumPy, Pandas, etc. 4, it adds strong type checking to the language. You can still use dynamic types if you prefer, but static types are essential for optimized performance and error checking. For memory management, it has an ownership system and borrow checker similar to Rust, and also supports manual memory management with pointers like C++. It's a pragmatic language that gives you safety, but also the flexibility to be unsafe when needed. Now, the final thing to know is that currently it's not available to the public. It's still in very early development. It will be open sourced in the future, but currently there's a waitlist to try it out. I was lucky enough to get early access, so let's fire it up. To run it, you can create a file ending in .mojo or .fire emoji. That's a huge advantage over Python, which doesn't allow you to name your files in .snake, but we can also run the code in a Jupyter notebook, where it behaves like an interpreted language. Here we have a matrix multiplication demo that computes a dot product to demonstrate the crazy performance gains we get with Mojo. First, it benchmarks a basic function in Python, then by simply importing that code into Mojo, it's executed 14 times faster with no modifications to the code. But we're only just getting started. We can further optimize this code by adding types to the Python implementation. Mojo allows us to do that with its built-in struct keyword. A struct is very similar to a Python class, but structs are static, unlike classes which are dynamic. Inside the struct, we also have keywords like var and let, which can define mutable and immutable variables, and def is replaced with fn, which is a stricter type of function. Also notice single instruction multiple data, which is a built-in type that represents a vector, where a single instruction can be executed across multiple elements in parallel on the underlying hardware. Once we have this struct, we can then use it as a type in the Python implementation. Then when we benchmark the code again, we get a ridiculous 500x performance boost, but we're still not happy yet. In the inner loop, we can query the vector width instead of hard-coding it, and that gives us a 1000x gain, but that's nothing compared to what we're about to do. Linear algebra is perfect for parallel computing, and we can easily make our code multi-threaded with the built-in parallelize function, increasing our speed buff to 2000x. But now I've got a fever, and the only prescription is more performance. Luckily, Mojo has built-in tiling utilities that basically allow us to cache and reuse data more efficiently, and we can even auto-tune it to find the optimal parameters for our hardware. The end result is over 4,000 times faster execution compared to the original Python code. That's pretty crazy, and if you want to see this code broken down in greater detail, I'd highly recommend this video from Jeremy Howard. But I'm curious what you guys think. Do you really think Mojo could kill Python and C++ at the same time? I'm a bit skeptical, but employers are already hiring Mojo developers with 10 years of experience. This has been The Code Report. Thanks for watching, and I will see you in the next one.